Okay, guys, we have this question on the board and we are asked to solve this. It looks complex. For some people, it looks simpler. But as a mathematician, you enjoy solving math because it's what? It's hard. But if you think this is simple, you can just pause the video and try the question first before going back to watch. But don't forget to follow because if you don't follow, you might miss out. Now, so let's try it. Now, I'm going to be using a different approach. There's a law I'm going to be using to shorten it up. And this law, I've been proving it what in my previous video, so you can go back and watch if you don't understand. So I have solution. Now, if you can remember, or you've been watching my video, you can see that there's a law I gave that has, if I have log a to the, let's use b to the power of n, for example, and a base that can be raised to a power such as a to the power of m, it can still be expressed as n all over m log a b to base a. So I'm going to be applying this to this. Because if you look very well, the base here can be raised to a power. The base can be raised to a power. So I can apply this law here. Now let's do it together. So from here, I can have this is, since it's just, the base cannot be raised to the power of here. It's just one. One, that is 1 and 1. So it's the same thing. I'll just bring it down to x. So applying that here now, I would have what? I would have that this can be expressed as plus log x to base 2 to the power of 2. Definitely the base can be raised to the power plus log this also 2 to the power of what? 4. X to base 2 to the power 4, right? Equals 21 all over 4. I'm doing something now. So I can just put 1 here to make the value of n. I get it now. So applying this here now, I would have log 2 to x to base 2 plus, I'll bring this and this here. That is n and m. So I have 1 all over 2 log 2 x to base 2 rather plus the same thing 1 all over 4 log x to base 2 equals 21 all over 4. So you can see that something is common to all each term here. I can factorize, right? So I'd have this as log 2x times, or use a bracket, is multiplying. So when I factorize 2x to base 2, I would have what? 1. Factorize here, I would have what? Half. Factorize here, I would have what? 1 over 4. Multiplying can lead me back to the same thing, right? So equals what? 21 all over 4. Now let's bring this here. Let's work with fraction. And I'm going to be using equivalent fraction method to solve this rather than LCM method. So I'd have this is equals log x to base 2 bracket. Now I'm going to try to look for a way that the denominators can all be the same. So I have 1 all over 4. That is 4 times 4. Multiply both up and down by 4 so that they can be the same. Plus, same thing applicable to here. I multiply by what? 2 and 2. That is 2 times 2 times 2 to make the base to be the same as 4. Plus 1 all over 4. I won't multiply that. Why? Because it's already in 4. So you can see that I've been able to what? Express all of them in what? In denominators of what? 4 equals 21 all over 7. So this leaves me with log x to base 2 bracket. I pick one of them, 4. So I had the numerators 4 plus 2 plus 1. This is another method of solving fractions. So equals 21 all over 7. So I would have this as log x to base 2 times what? This is 4 plus 2 plus 1 gives you what? 7 all over 4. Right? Please change this to 4. We had 4. We had 4. From the beginning it was 4. So I'll take equals what? 21 all over 4. Right? So if you look this now, I'm trying to get to what? Make the x that is on our left hand side to be on its own. So I have to get rid of the fraction by dividing both sides by this fraction, right? So I would have log 2x equals 21 all over 4. Let's just divide and reciprocate at once. This will be divided by 7 all over what? 4, right? So taking the reciprocal now, I will have what? Times 4 all over 7 to multiply fraction. I don't want to go because I have enough space again. So I would say this would cancel this and this would cancel this. This 1 1. 7 to itself 1, 7 to 21, 3 times. So I have log 2 x to base 2 equals 3. Right? So changing this into an initial equation now. You would have what? X equals to what? 2 to the power of 3. Therefore, x equals to 8. Now, how do I change this? You should always remember the definition of logarithm. Logarithm is what you can raise the base to give it that number. So to change it to an initial equation, now what do I do? 2 to the power of 3 would give me x. What can you raise the base to give it that number? I see now. So 2 to the power of 3 gives me what? X. So I have this. Thank you for your time. Don't forget to follow for more.